All right, we recording yet? Yeah, we're recording. Here's the answers to all three periods for the lesson quiz spot check 31. It was on interpreting functions. This one was the introduction to rational functions, remember. So first we had to identify which one is and is not a rational function and why. For number one, both a ratio of polynomial functions, whole number exponents, and this one could be written as a polynomial function or rational function as well. So yes, the answer is that one. Whole number exponents is a ratio of polynomial functions. For number two is a no, because the variable in the exponent makes this part an exponential function, which is not a polynomial function. So number two was a no. For the graph here, you had to state all the 6 features that we talked about in class, and I tried to delineate where the asymptotes were to help figure out all the things. And on this one and this one only, I wrote down some words that would help you attain a 4-level mastery in your explanation to make sure that you demonstrate that you know the concepts. So remember, the domain is our possible x values as we go left to right. Where is the domain? It goes from negative infinity to negative 2, and then it stops. We can't have negative 2 because that would make this function undefined. And then it goes from negative 2 to positive infinity, and we have to put the union symbol to denote that the domain is actually the union, the joining of these two separate sets. And the domain is the possible x values to demonstrate mastery. We do the same thing for the range, but for the range we start down at the bottom at negative infinity and go up to positive infinity, whereas the breakpoint, the horizontal asymptote in this case, is negative 3. It appears there and there. I had a lot of students on domain and range switch these two values left to right. Got to remember that it's going to start from negative infinity and goes to positive infinity for both domain and range, so those should be the outside symbols. Now the end behavior, it's not up down now. The end behavior as x approaches negative infinity is going to be right here, this horizontal line, y equals negative 3. And you can also say, to demonstrate mastery, that the ends are the same as the horizontal asymptote, which is where that breakpoint is. Now we need to talk about some limiting behavior. And limiting behavior is again related to the vertical asymptote. What happens to the graph of the function as x approaches negative 2 from the left and right side? This means negative 2 from the right side. This means negative 2 from the left side. As you can see, the function on the right side tends toward positive infinity. That's where we get that. And as we approach negative 2 from the left side, the function tends towards negative infinity. Okay? And here is function behavior as x approaches the vertical asymptote. That's your concept for what the limiting behavior is. This function never increases. It's always decreasing. So increasing is never. You get that by looking left to right, just like domain values. And we can see by inspection it's never increasing, but it is decreasing all over the place except at our negative 2, which is in this case the same as our vertical asymptote. Usually you can see this expression right here is the same as the domain. All right, that's it.